Hello and welcome to the 11th video in this series making simple Flappy Robin for the iPad and iPhone using Cocos2d. So last video I forgot in the intro scene.m there is a function somewhere here called stop game, I believe. If I can find it, here it is. In stop game, or indeed start game, it's been a while since I did the last video, I can't remember, but I had I think the stop call on the tube objects, this loop here in start game, and this loop here calling stop all actions on the tubes in stop game. I'm not sure whether I actually showed those being programmed in the video. The reason for that is I usually prepare for these videos by doing the code in advance, making sure I know what I'm doing, or trying to, then deleting the code and starting the video again. And sometimes I forget to delete parts of the code, and that's exactly what happened there. I think I put a comment also in the 10th part in the video, in the description section, to say that I'd missed it off as well, but it was there in the download. I apologise for that, but that sometimes happens because I find it difficult to keep track of what I've done and what I haven't done. Okay, so in this video then what we're going to do is we're actually going to get the Robin colliding with the tube, so we're going to add in some collision detection. Now the way we might, we would think at first of doing this is simply inside the update function, if I can find it, and I can't find any of the functions today. Good, here's update. Would simply be to say somewhere in here we've got the game over call if the position is below the floor, so we could say something like, or we will say else, and here then what we'll do inside this else is we'll then loop through each of the tube objects, and we can ask if the rectangle covering the tube intersects the Robin's rectangle. However, that brings across a couple of problems. One of the problems in general is with the tube image, which you see here, the bounding box for this tube will actually include this extra grey here that's covered by the width of the bottom of the tube. So where the lip comes out there, that'll make the bounding box actually the width of the base of the tube and then the height of the whole tube. So if we did right to the edge of the tube, it'll look like the Robin has not actually collided with the tube yet, but yet a collision is detected. Now the way to go around that is to write a bit of code that's a little bit complicated really for this series. It's not necessary. You'll get the idea of how to do it with what we're going to do with the Robin, because the other thing with the Robin is that I just bring up the Robin's PNG. Let's bring up a high detail one so we can see it. Now the bounding box for the Robin will actually start here right at the edge of the tail, will go as low as the bottom of the foot here, as far along as the beak here. So if you imagine a box surrounding the Robin, if we were here where the mouse pointer is now, a tube hit there, then that would be counted as a collision because that's inside the bounding box. So what we need to do is we need to take the bounding box of the Robin, but we actually need to move the X along a bit. So really it starts the bounding box at the back of the body. And then what we want to do is we want to move the bounding box up a bit so that it's somewhere, let's say level with the bottom of the red breast here, so it's not right at the bottom of the feet. Then we'll take off the beak, so we'll make the bounding box width then the same width as where the tail begins here up to the beginning of the beak, so basically the circular body. And then we'll probably make the height just go up to where the hair begins here. So the bounding box really is sort of a box that contains more or less the circular body, and the rest doesn't really matter. And it's a bit of a hack to do it like that. Obviously what you'd really want to do is write something more complicated, which involves rotating, say, a box and rotating the tubes box, and you can look that up online, how you go about exact collision detection between rectangles, or even take this as a circle and do a circle colliding with a rectangle. There's loads of stuff online on that. I don't want to go into that in this series because it'll be too much code, but we're going to do a bit of a hack and just make the Robin have a smaller bounding box that we use for our collision detection. And in effect in the game it actually works reasonably well, and when you play it you don't really notice these problems. The main thing is when you get a collision with a tube that there isn't a gap. As long as the Robin is overlapping the tube slightly, then I think the player doesn't really notice much. So to do this then, we have bounding box available, which is a CG rect in Robin. We need now to add a new function which also gives us a CG rect, except this one we'll call the tube collision box. So this will be a function then that returns the bounding box adjusted for collisions to tubes. So I'll just go into the implementation file then, and we can implement this function. And it's not very difficult, you'll be glad to know. We can return already, and there's a CG rect make, I think, yes. And now we simply have to give the X and the Y. And so we'll have self.bounding box, and we've got the origin, the X origin first. Remember, I want to move that along, so I'm going to move that along 13 based on our original 480 wide screen, and then obviously I'll multiply this by the Y scale factor to allow for the iPad. And I'm just going to take all these out now like this so that we've got a bit cleaner code, and just copy and drop this in. So we want the origin then Y, so we're basically with this 13 taking out the tail. And now we want to move the Y up a bit to take out the feet, like I said, again multiplied by the Y scale factor. And now what we want is the size, and we need the width. And remember, we're taking out the beak here, so I found that minus 17 was about right in the total width, because remember we've moved the origin along 13, so we're going minus 17 multiplied by the Y scale factor. And then last but not least, we've got the height, which also we need to reduce, and I found 8 to be about right here. And what that has the effect of doing then is, this is then this smaller box surrounding basically the circular body of the robin, which we can then use for our collision detection. So if I go back into intro scene, and then let's go into the update function, let me just find it. And what we want to do then inside this else here then that I've already put in, we want to now see if we collide with the tube. So what we'll do is we'll say for, and I'll use the for in, and then we want to see tube, pointer to tube, and it's in tube objects. And now what we can say is, we can say that if, and it's CG rect intersects rect, and we want rect 1. Oops, I've called that tune, not tube. Just call that tube. So we want the robin, and now what we want to get from the robin then is the tube collision box. So if the tube collision box intersects the tube dot, and we'll just use the bounding box for the tube, then we know that we have a collision here. So we'll just log to the console then that we have a collision. And when we've got the tube collision, then we're in the situation where the game now is over, so we can say the game over equals yes, just as when the robin collides to the floor. And then what we can do is we can simply then break out of the loop for the tube objects, because we've already found a tube that we've collided with. So that's all we actually need to do then to get the collisions working. If I just run the application now, and now hopefully when I run the game, the robin should collide. I'll deliberately come along and try and collide with this tube here, so we can actually see the robin colliding with the tube. This is the Retina 3.5 inch iOS 7. And now you can see that the robin has collided. What's happened here, the reason it's moved up is because the reset to the middle of the screen happens then instantly. We'll put the pause in there that you see if you've played the Android version of the game. The pause that we have there will actually put in later on, obviously. But for now, what's happening is the collision happens, then it's an instant reset. So here it collides and resets. So at least it looks like it's colliding. I'll just do one more where we try and get over or past a couple of tubes and make sure there are no problems there. And all looks okay, good, it's got through. Now just collide with this tube up here then, and good, everything's okay. Good, so that's tube collision detection working then. What we'll do in the next video then is we'll put a label on the top left hand corner of the screen so we can actually keep track of the score and how many tubes we've managed to get past. So I hope that's made some sense. Thanks very much for watching. Comments, questions, criticisms welcome as always on YouTube.